Hello, today I'm going to talk to you about molar mass, and molar mass is just the mass of 1 mole of something. Okay, so we talked about in the previous video that a mole could be anything, right? Usually we're talking about molecules or atoms, but a mole of them is 6.02 times 10 to the 23rd of that item, so a whole bunch of them. All right, so let's talk about how we would figure out what the molar mass is. Okay, so the mole was defined so that 1 mole of carbon is exactly the same mass as the atomic mass that's on our periodic table. Okay, so we learned before that the average atomic mass is that number at the bottom. So for carbon, it's 12.011. Okay, and then the molar mass would then be the same number, but the units would be different. So the units are going to be grams per mole instead of atomic mass units. Okay. So all you're literally going to do when you're trying to find the molar mass is find the element on the periodic table and look for that number that's below the symbol, okay? And when you're doing that, if I asked you to find the molar mass, always record all of the numbers that are on the periodic table. Usually it's 3 numbers after the decimal. Okay, and then a reminder back from earlier in the unit, if we have something that's grams per mole, that means we can write it as a conversion factor. So that means that there's 12.011 grams in 1 mole of carbon, or 1 mole of carbon is 12.011 grams. Okay, so just a couple more examples. You could even pause here and find the molar mass of hydrogen and iron, and then play it again and see if you got them right. So for hydrogen, it's going to be 1.008 grams. And again, I just got that number right off the periodic table, right? Which means that these are the conversion factors we can get from that. And for iron, the molar mass is 55.933 grams per mole. Okay, and if I ask you for the molar mass, this is the answer. I just want you to be aware that you can get conversion factors from it as well. This is not the molar mass. It's the conversion factor that you get from the molar mass. All right, so now let's say we had a molecule. All right, so 1 mole of water is going to be 2 moles of hydrogen atoms and 1 mole of oxygen atoms, right? So remember that if there's nothing there, that means there's 1. But then if there's a subscript, that tells you how many there are. So we're going to add up the molar mass of hydrogen from our periodic table, which is the 1.008, and the molar mass of oxygen, which is 15.999. Okay, so if we add those up, all right, just 1 of these and 2 of these, we get 18.015 grams per mole. All right, and again, that can be written as a conversion factor, which we're going to use in the next lesson. All right, so here's just a couple more examples. Again, I would suggest that you stop the video, try to do them yourself, and then play and make sure that you got them correct. All right, so 2 lithiums and a carbon and 3 oxygens will look like that. And we'll get a molar mass of 73.890 grams per mole. Remember to carry all of the digits that you get from the calculation. Right? For sodium chloride, that's 1 sodium and 1 chlorine, so you'll get 58.443. And now this last one is a little bit trickier. This has a polyatomic ion in it, and there are 2 of it. So there's 2 ways that you could write this. You could either do 24, which is the mass of magnesium. The 2 does not apply to the magnesium, okay? It's not in parentheses. The 2 only applies to the stuff inside the parentheses. So you could either do 2 times that whole thing in the parentheses, which is a nitrogen and 3 oxygens, or you could distribute the 2 and do 2 nitrogens and 6 oxygens, and it will get you the same answer. So it is up to you which way you want to do it. It really does not matter.